Welcome you all for this video call lecture. Today we are going to discuss about the structure of silicates. So what are silicates? Silicates are the compounds of oxygen, oxygen and silicon compounds are generally called as silicates. The silica, the most abundant material available in the earth crust. 80% of earth crust consists of silica. For example, in the seashore side, we saw a lot of sands. The sands mostly consist of nearly 80% of or 80 to 90% of silica in the form of silicates. So silicates are the minerals containing silicon and oxygen in tetrahedral structure having the general formula SiO4 minus units, which are linked together in several patterns. Based on the linkage between the silicate units, they are classified as several types. About 95% of earth crust is composed of silicate minerals, aluminosilicates, clays, or silica. Silica, why we are studying about the silicates? Silicates are extremely important because the cement, ceramic, and glass industries are based on their chemical composition. Metallurgical extraction processes often produce silicates as waste products or slag, either because the minerals are silicates. So the silicates are obtained from silicic acid. The silicic acid having the general formula H4SiO4. When we are removing the H4 plus ion, we got SiO4 4 minus ion. This is the basic structure of the silicate unit. And also it having sp3 hybridization. It involves a silicon-oxygen-silicon bond available in the silicates. So I already mentioned that the classification of silicates based on the silicate units are combined together, or depending upon the way of the tetrahedral units are linked, the silicates are classified into the following types, namely orthosilicate, pyrosilicate, cyclic silicate, chain silicate, double chain silicates, seed silicates, and finally three-dimensional silicates. So orthosilicates are generally called as a simple silicates. It consists of only SiO4 units. The SiO4 units, I already mentioned it is a tetrahedral units. Simple tetrahedral units are called orthosilicates. The silicon atom is a central metal ion. It is linked with the 4 oxygen atoms. The 4 oxygen atoms having minus charge. The silicon is 4 plus 4 oxygen atom is there. Each oxygen atom having a charge of minus 2 ion. So silicon Si4 plus O4 8 minus. The final net charge is SiO4 4 minus tetrahedral units. The orthosilicates are generally called as simple silicates. Some of the examples of orthosilicates are willimanite, porphyrite, phenicides, etc. The second one, pyrosilicates or sorosilicates or disilicates. Here, the 2 silicate units are combined together by the removal of 1 oxygen atom. The general formula of pyrosilicate is Si2O76 minus ion. And the third one is cyclic silicates. The general formula of cyclic silicate is SiO3 n times 2n minus, containing 3, 4, 6, and 8 tetrahedral units are combined together in the cyclic form. That is called cyclic silicates. Beryl is a famous example for this classification of cyclic silicates. And fourth one is chain silicates. Here, the simple chain silicates formed by sharing oxygen atom at 2 corners of each tetrahedral units. The general formula is the same one as we are studied in the cyclic silicate. Here also the chain silicate having the same general formula The oxygen atom shared here the two corners of the each tetrahedral gives the chain silicate. And the double chain silicate can form the two simple chain silicates are joined together by shared oxygens are called double chain silicates. They are generally called as ambiboles. Ambiboles is Si4O11 n times 6 n minus. Double chain silicates. Two types of tetrahedral, those sharing three vertices and those sharing only two vertices. Some of the tetrahedral sharing three vertices and some of the tetrahedral units are sharing only the two vertices. The sixth one is seed silicates having the general formula Si2O5 2n minus. Each SiO4 tetrahedron shares three oxygen atoms with the other and thus forming two-dimensional seed. These seeds can be cleaved easily just like graphite. So talc is an example for seed silicates. This is the structure of the seed silicate. It is also called as a pyrosilicates. So the final one is three-dimensional silicate. The structure of three-dimensional silicate, all the four corners oxygen atoms of SiO4 units are shared with others. So the three-dimensional lattice formula is SiO2. The general formula D-dimensional tectosilicates SiO2 n type. That is the general formula. Quartz is an example for this type of examples of three-dimensional silicate. This is the structure of three-dimensional silicate. It is also called as tectosilicates. Here, the four oxygen atoms of the tetrahedral units shared with each other. So this is the classification of silicates. And this is the silicates. I already mentioned it is used in glass and cement industry, and also soaps and detergents, textile industry, and fire protection industry. There are a lot of uses of is there in the silicates. That's why we are studying the silicates. Thank you for watching this video. Thank you.